Like you said, my name is Zach Miller. I am a senior data scientist with Metis, which we're here in town, and what we do is data science and machine learning education. So my day-to-day life is basically teaching people how to do data science. So with that in mind, you can see that I probably have a vested interest in getting people into data science and then making sure that they don't do dumb things once they're doing data science, that data science continues. If data science ends, then I don't get to teach people to do data science, and I will not be as happy as I am right now. So with that in mind, what I want to focus on today is dispelling some common myths that beginners run into when they start doing data science. And let me give you some lead in to why I'm going to talk about this. So I gave a talk last year at this very conference about how to learn machine learning in 6 months. It's basically like a roadmap about learning math and programming and things like that. And at the end of that, I did something that I now kind of regret because it was relatively dumb. I assumed that no one outside of this room would ever in a million years care about what I said, because that's pretty accurate to most of my life. So this is me assuming that no one will ever watch this last year. This is my actual email address, and this is a very non-zero number. So what ended up happening is that for the past year, people have been bearing their souls to me in random emails about data science. And at first it was very, very confusing because I started getting emails from like China and India and Russia, and I'm like, how do you know about me? And then I finally tracked down that like that video had taken off and people were finding my email address at the end of it. So I'd like to give you a sample of one of these emails so you can kind of get the full experience. I've removed the name for privacy reasons. So, ever since I finished my economics degree, I've been grinding at a horrible company. I hate getting up and going to work. Data science seems interesting and more fun than what I'm doing. Should I just keep grinding and hating my life? Or do I have what it takes to become a data scientist? And here's the best part of all this. The very first thing that I've taken out with dots was hi. The very last thing in the email is, oh, by the way, my name is X. So this person doesn't greet me, and then just pours out all of the worst possible, and then says, hey, can you help me? So I live my life by very few rules, but one of them is don't ask for help from people on YouTube. So when people actually do that, I feel like a responsibility to actually say, okay, I'm going to try to help these people out. So I've answered literally hundreds, maybe up to 1,000 emails over the past year of people asking me for life advice, which is a terrible decision. So I tried to distill these questions down into like 3 very common myths, 3 common things that people tend to ask about. And so I think these are the big 3 of what I've been seeing. So the first one is, should I learn deep learning or machine learning? So if you're in this room and you haven't heard the word deep learning, I would be very, very surprised. It's like so buzzworthy, so many keywords popping up. And then machine learning is another one, and people don't really seem to understand the difference between the two. So today I'm going to try to tell you my opinion and what we see. Do I really need to know how to program and or code? And then finally, how sciencey is data science? So these are sort of the 3 main questions that I get over and over in all of these soul-bearing emails. So with that in mind, let's go ahead and answer the first one. Should I learn deep learning or machine learning? And if you vehemently disagree with me on this, we can fight afterwards, it's fine. But in my opinion, I think you should skip deep learning to begin with. If you're a beginner, if you're first getting into data science, deep learning is not the first thing you should learn. So let's explore that a little bit deeper. For those uninitiated, let's talk about what deep learning is. This is going to be an insultingly short recap of deep learning, which is basically deep learning says, okay, I'm going to take some inputs, which are the grayish blobs on the left here, and then I'm just going to basically add a bunch of parameters, and I'm going to let those parameters try to figure out what the answer should be. I'm going to try to make a prediction, which are the things on the right in red, and I'm just going to add as many parameters as I can, and I'll let the machine learn about things. Okay? So the thing about that is there's a lot of arrows. Like this took me like 5 to 10 minutes to draw. So with all those arrows going on, there's a ton of stuff that you have to be keeping track of, but it is a very powerful technique. So why do we like deep learning? Because it does some pretty cool stuff. This is why it's becoming famous, essentially. So here is a real-time video, and you can see that it is drawing boxes around the cars. So if you're doing computer vision, you're doing trying to make a self-driving car, this is a great technique, right? I don't have to do a lot. I put it into a deep learning model, I figure out my deep learning model architecture, and boom, I can find cars. Great. I can also do things like, this is a mathematical proof as written by a machine. So it learned about how to write latex code, and then it basically, they taught it how to generate pages of latex code, and it learned, hey, maybe I should put some equations in here, maybe I need some lemmas, maybe I should make a diagram. Now, all of the mathematics and text is absolute garbage. Like, it's just junk. But it's learning that technique of how to write latex, and when it does that, you can immediately see, like, this could be a really cool tool if I need to generate new things later. And that's something that deep learning is really great at. Finally, Google uses deep learning also in auto-translation. So here's an example where it looks at this picture on the left, it finds the characters, and says, hey, I know what those characters are in language X, let's go ahead and convert them over to language Y, and then show that to you in real time. So this is another really cool example of deep learning. So after I say all of these things that look really, really, really cool, why do I say go ahead and skip deep learning? So there's a few reasons. The first one is neural nets are basically an extension of traditional machine learning. So if you can do traditional machine learning, you can then learn how to do neural nets and deep learning later. If you don't understand those traditional techniques, no matter how much of a neural net wizard you are, I personally don't want you on my team. I would never hire somebody that just comes in and says, hey, I really know neural nets, but I have no idea what a logistic regression is. Right? That person is out the door. That interview is over. And that's not just me. So I said that I'm a data science educator. One of the things that we do is we talk to employers all the time. So here in Chicago, we're always talking to employers like, hey, I sent you person X. Did they have the tools and skills that you wanted them to have? Hey, come watch all of our students present on projects they've made. What tools and skills do you think they need to be successful in your business? And one of the things we hear all the time is, yeah, it's great that your students can do computer vision on the fly with neural nets. That doesn't apply to my business at all. I don't care. That's a great skill, and I have no use for it. So neural nets and deep learning right now are still sort of in the realm of academia. There are businesses that are using them. They're starting to use them. But most businesses aren't ready for that yet. So that's not just me being kind of a jerk about it. It's actually the sentiment out there in the world right now. On top of that, neural nets and deep learning are extremely complicated models. So remember all those errors? That's a very small neural net, and each one of those is a parameter that the machine has to learn and tune. And so I've shown you maybe 20 parameters. It's not uncommon to have neural nets with millions of parameters. And so when you get these super complex models, you have to have somebody that understands deeply what's going on and has a good gut feeling about it and things like that. And if you're first beginning in data science, you're not there yet. And you're gonna have to take the time to ramp up to that. In the meantime, you should be learning skills that are more applicable to begin with. And in order to get your neural net set up, you also have to have some way of designing your architectures, right? You have to say, okay, I showed you one simple architecture. It was like two nodes, 5 nodes, 4 nodes, 2 nodes, right? But that isn't a rule of thumb. That's just something I felt like drawing. And the rules of thumb for designing your neural net architectures are actually quite hard to come by. They're very complicated, they're very finicky. People get good at building them, but there's no one that's just like, I automatically know the correct architecture no matter how great they are. So that's going to be a huge time sink when you're first trying to learn data science. On top of that, like really sinking into the deep learning here. So on top of that, your complicated models really need a ton of data. And most businesses, I mean, you've got your Googles, you've got your Apples, they have the time and the resources and the data to do that. Most businesses don't have the time, the resources, and the computational power to actually train a huge neural network. Even if you do have cloud computing, as Dave was talking about, that still takes a lot of effort and a lot of person time. So even though we're getting these cloud computing services that are making it easier and easier, it's still not to a point where, you know, Joe guy that you just hired can just drop in and do that. And so since they don't have, most businesses don't have the resources to effectively weaponize deep learning, they're not putting the time and effort into it, which means that if all you know is deep learning, you're not very hireable. And then my last point is that there's a lot of regulated industries out there. So think banks, think loans, think medical, all those fields where the government has a vested interest in making sure your model is not being a racist. Those industries aren't allowed to use deep learning a lot of times because people still think it's too much of a black box. I don't know which part of my model is targeting minorities and rejecting loans. So I can't go in and say, okay, great. This is the part of my model I'm going to change. This is the part of my model I'm going to adapt. And then this is just my little minor soapbox, so I'll make it very minor, which is It's not a black box, it's the chain rule from calculus. If you don't understand that, I will talk to you after this and we can have a long chat about the chain rule. Very passionate. Okay, so that's the deep learning question. The next question that we want to come back to is, do I have to know how to program? And I would like to postulate and put forward that, yes, you need to know how to program like you're not an idiot. The reason for that is, let's take a look at this whole definition for data scientist. So, data scientist is a person who's better at statistics than any software engineer and better at software engineering than any statistician. This is a definition that people use all the time when they're talking about data science. And I would like to highlight one thing. 2012 is not 2018. So this was a very accurate definition in the infancy of data science booming, when it started coming up, right? All you had to be able to do was write enough code to get to some module that somebody else wrote and get the data into that and get something out, and you were the magician and you got $100,000 and you got pats on the back all the time. That gap has closed quite a bit, and there's a couple reasons for that. First, data is no longer just sitting around in flat files and text files. People aren't just walking up to you and saying, look, you're the data scientist here, have all our files, please make it work, right? Now they're saying, we have a team, and that team stores data in a data warehouse, and we use a cluster computing methodology, and if your code doesn't run on our cluster, you are useless to me, right? You can no longer just be like that one person that sits in the corner and gets the text file and then does like magic. And you still do the prototyping that was traditionally assumed as part of a data science role, but now when it's done, it has to be a product that can be productionized. It's no longer sufficient to come up with an insight like it was in the infancy of data science. You have to be able to say, okay, I came up with an insight, and here's the model I used, and here's how you put it into your production environment, and here's how you can scale it out. All of that is now mandatory for data scientists. And that's basically because your data science teams are no longer just one weird physicist that celebrates Pi Day, microwaves fish, wears sandals all the time. Like, that's the life. Believe me, I wish I was living that life, but it's not the life that exists anymore. So your code is part of a stack that your team relies on day in and day out. And so you have to be able to write code like a real human being. Jupyter Notebooks. I'm glad actually that David mentioned these because I was hoping that I wouldn't have to explain what they are. So those are those on-the-fly things. And for the most part now, you can do all of your designing, your scaffolding, your playing around with data in these Jupyter Notebooks. But when you get done, you have to write a Python module that you hand off to your production and engineering team, and they say, great, I'm going to put this into our pipeline, and now your model is going into production. If your model lives in a Jupyter Notebook only, it will never go to production. No one's going to sit around and hit Shift Enter to run the cell when we get new pieces of data. I would also argue that you have to know how to optimize your code, and even if you are on a small team, you really shouldn't be treating Jupyter Notebooks as the endpoint for your data science, right? If you are, you're just begging for people to come back and ask you questions and to run every new piece of data through. If you build a nice piece of pipelining that takes data in and puts out predictions, then you are now making data science that can scale, right? And scalability is sort of the new thing between 2012 and 2018. All right. The last piece of advice when you're talking about coding is document your code. Write comments. Write in exactly what this piece of code is supposed to do. Make sure your function names are accurate, right? Don't name your variable X. If you do, the rest of your team gets to punch you. You are not an animal. If you are a data scientist, you should be writing real code that works. Right? All right. And then finally, how sciencey should data science be? This one, I think, is still somewhat up in the air, but I would argue that data science should be science done with data. Okay? So, what do I mean by that? This is an insultingly short way of, I'm doing a lot of insultingly short things today. Insultingly short way of doing science, right? I come up with a hypothesis, I design an experiment to say, okay, how do I test whether my hypothesis is accurate? I actually run the experiment, and at the end I evaluate what happened. I pull out some statistics, I say, does it do what I think it does? Is it statistically significant? What's my p-value? All of that nonsense. Not nonsense, but all of that rigor. This is the data science cycle. Notice that I've just changed the word experiment to test, right? How do I optimize my business? I have an idea. That's my hypothesis. How do we test that? I redesign our website and we do A/B testing. Okay, do that. I run my actual test. Now, how much did it actually change our business? Do I see an actual growth in my business? I have to evaluate that, right? I have to get in and do real metrics. I have to have an exact solution to what do I say is a success for my test, right? That's just the scientific method. You just aren't calling it experiments, you're calling it a test. And the other piece that comes along with this is, I really hate this phrase that gets assigned to data scientists, which is that data scientists are just data storytellers, right? I find some story in the data and I tell my business about it. And that's just wrong, right? We, as data scientists, are not storytellers. We're investigative journalists / interpreters, right? Now, I've got a few key points why I think that. So, if I'm a storyteller, I have liberty to leave out the boring parts of my story. Right, so let's say I'm hiking up the mountain and Stu falls off the mountain and breaks a leg. That's a great story. I don't have to talk about the part where we walked a mile and a half and Stu didn't fall off the mountain if I'm just telling that story, right? Like we're just hiking up the mountain, nothing's happening, and then Stu falls off. I don't have to talk about how tired I was because we walked a mile and a half. If I'm doing interpretation, I have to find a way to convey the confusing and boring parts to the non-technical party, right? I have to go to the data, I have to figure out what's in the data, and then I have to say, okay, I know my CEO does not understand data at all, right? He's a business person, I'm a data person, I should not be a business person, he should not be a data person, we have to communicate. And so I have to find a way to say, okay, this is what's in the data, and let me tell you about it without using the term adjusted R squared, because you don't know what adjusted R squared is. I don't get to leave out all those boring parts. A storyteller can also change the facts for the sake of the story. So maybe I say that Stu fell off the mountain while trying to run away from a badger, because that's a way funnier story than Stu fell off the mountain because he tripped over a rock, right? If I'm an interpreter, I don't get to do that. I have to say, these are the facts, this is the data. If I'm doing language interpretation and I change the meaning from one party to the next, I am not a good interpreter. And if I'm doing data science and I change the meaning between what's in the data and what I tell the business side, I'm not doing good data science. Finally, the last sort of small point is that a storyteller doesn't need to prove anything in the story, they just have to make it entertaining, right? And that doesn't fly for data science either, partially because talking about data science is rarely entertaining. And partially because if you're trying to make something entertaining, you're going to be basically making things up that make it more entertaining. And if you're doing data science, you don't have that liberty. You have to use statistics to justify everything. You have to have the exact values for why you're making a decision for the business. You don't get to just throw things out, and you don't get to make things up as you go. All of it has to be based on what the data says. All right. So that's a long-winded way of saying basically 3 key points, which is, my opinion, should I learn deep learning or machine learning if I'm a beginner? Start with machine learning. Deep learning is an extension of machine learning. You can get there. It does some really cool things, but if you're not doing machine learning first, you're not ready for deep learning. Do I really need to know how to program / code? Absolutely. 2018 is not 2012. There are data science teams. You have to productionize your code. It's not sufficient just to hack away and get it into scikit-learn and call it a day. Finally, how sciencey is data science? It's pretty data science, or pretty sciencey. But I also would argue that it needs to get more sciencey going forward, right? We're at a sort of a turning point with data science where people are starting to get sort of disenfranchised with it. It's like, you made all these predictions, but not all of them were true. Yes, that's how probability works, that's how statistics work. Now we have to explain that in a scientific way, day to day, and make it a more sciencey procedure. All right. So with all that said, allow me to do one last thing, which is probably going to be done again for next year, but here's all my contact info. So if you have a project that you're thinking about, or if you're doing some cool stuff with data science, or if you just want to talk to me about like what is data science, let me know. I'll be around for a while. Here's all my contact information. You're welcome to send me an email, and I will get back to you. And thank you for your time. Any questions?
So with your training, can a non-science person become credible as a data scientist?
Absolutely. It's going to take more work, I think, as a if you don't have a background in science and data analysis to get there, but you can absolutely pick up the skills. I mean, the skills themselves are just some linear algebra, some calculus, and some statistics, and then learning to program. And then the rest of it is data science specific things that you can pick up by going to blogs, going to the internet, finding examples. Like there's nothing super special about data science other than it's a conglomeration of skills that you have to practice to get there. And we've seen that, so like I work in education, as I said, and we see people come through all the time that aren't statistics PhDs, that aren't scientists or mathematicians. They're just people that were in jobs before and don't want to be in those jobs anymore. And we work with them, we get them up to speed, and they do end up becoming data scientists. So
it was mentioned that your background is data analytics. So what is the difference between data analytics and data science?
So the question is, what's the difference between data science and data analytics? And the answer, unfortunately, is I have no idea.
Question all the time.
Yeah.
Because I work in data analytics and people just get confused with my job is like data science, which is not similar, but it is similar. So that's why like I try to like understand like what's the difference.
Yeah, I mean, it's a fair question. And it really depends, I mean, what company. So if you, like I'll use Google as an example. At least a few years ago, I know that there were no data scientists at Google. They're all data analysts. You go to another company and there are no data analysts, they're all data scientists. And some of their analysts don't do anything but run reports in SQL. Or some of their data scientists just run SQL reports. There's nothing wrong with that, but that's usually the line that people draw in the sand, which is like, if you're doing only SQL, you're an analyst. If you're doing modeling, you're a data scientist. Or if you're working with data engineers and you're a scientist and not an analyst. And I honestly have no idea. I think the better way to talk about it, and I'm not nearly influential or smart enough to make this happen, but I think the better way to talk about it is, what do you do day to day, and what skill sets do we associate with modeling and things like that? And that should be the line we draw in the sand and say, hey, are you on this side of the modeling question or on this side? But people smarter than me have said that's not an accurate way to go, and they're smarter than me for a reason, so I don't know how to answer that question.
Can you go back a few slides to the modern data scientist? I need to take a couple more notes.
Which one?
The one before your notebook. Yeah, this one. Thank you. Yep.
Anything else? All right. Well, thank you for your time. Appreciate it.